Okay, find the max and min of f of x is equal to 3x to the fourth minus 4x cubed. Let's first find f prime of x. Okay, this will be 12x cubed minus 12x squared. So I can factor out 12x squared, and I'll get x minus 1. Okay, when is f prime going to be 0? Well, when x is 0, when x is 0 or 1. So when I make my number line, those are my critical numbers, and that's the only place that my function could change increasing, decreasing behavior. So we have to investigate if it actually changed the increasing, decreasing behavior or not. Okay, so let's look at the sign of f prime. Sign of f prime in the interval, these intervals, from negative infinity to 0. Well, imagine any number less than 0. X squared is always going to be positive. 12 is always positive, right? So only look at x minus 1. Negative number minus 1, of course that's going to be negative. Okay. Number between 0 and 1. Well, something less than 1 but bigger than 0 is a positive number, but you're subtracting 1 from it, so you're going to get a negative number. So there's a negative. And any number bigger than 1, you plug it in here, you get a positive number here. Everything else is positive as well. So there you go. Notice that 0 is a critical number, but this is not going to give you a max or a min, right? So because to the left of 0, f is decreasing, and to the right of 0, f is still decreasing, right? But what do we have at x equals 1? At x equals 1, to the left of it, here decreasing, decreasing, and this is going up to the right of 1, and you have a local min. So local min at x equals 1, and you have 1 comma, if you plug in 1 in the function, you get 3 minus 4, right? That's negative 1. There. So that is your local minimum. You do not have a local max. Okay, so let's look at the function. I graphed it here, right? Notice that here at x equals 0, even though the slope of the tangent line is 0 at this point, you don't have a max or a min, right? But x equals 1, that is a critical number, and at x equals 1, the y value is negative 1, and this is your local min. And this one happens to be a global minimum as well. And we're going to talk about that in the next example.